Stemming. What is stemming? Stemming is a technique used to extract the base form of the words by removing affixes from them. It is just like cutting down the branches of a tree to its stems. For example, the stem of the words eating, eats, eaten, etc. is eat. Stemming forms the root word of a particular word. Search engines use stemming for indexing the words. That's why, rather than storing all the forms of a word, a search engine can store only the stems. In this way, stemming reduces the size of the index and increases retrieval accuracy. We often see that in search engines, when we enter only a part of a word, the entire words come up in the suggestions. This is because the system has stored the root word, which is the stemmed part of a particular word. There are various stemming algorithms. In NLTK, stemmer 1, which has stem method interface, has all the stemmers which we are going to cover next. Let us understand it with the following diagram. The stemmer 1 method, the stemmer 1 has stem method, which has the porter's stemmer, regex, p stemmer, stands for regex stemmer or regular expression stemmer, snowball stemmer, and Lancaster stemmer. The first of these of the four stemming algorithms is the Porter stemming algorithm. It is one of the most common stemming algorithms, which is basically designed to remove and replace well-known suffixes of the English words. Porter stemmer class. NLTK has the Porter stemmer class, with the help of which we can easily implement Porter stemmer algorithms for the words we want to stem. This class knows several regular words, word forms, and suffixes with the help of which it can transform the input word to a final stem. The resulting stem is often a shorter word having the same root meaning. Like the like the word eating, eats, and eaten has the stemmed root word eat, which is smaller than the three words prior. Let us see an example. First, we need to import the natural language toolkit. First, we import natural language toolkit. Now, importing the Porter stemmer class to implement the Porter stemmer algorithm. We first import the natural language toolkit library, which can be given as which can be given in the statement import followed by the letters NLTK. This import NLTK simply imports the NLTK library and all the functions entailed within it. Now next we import the Porter stemmer class to implement the Porter stemmer algorithm. From nltk.stem, import Porter stemmer. Notice how we don't search for Porter stemmer library within the entire NLTK package, but instead inside nltk.stem package. This narrows down our search for the packet for the library Porter stemmer. Next, we create an instance of Porter stemmer class as follows. Word stemmer equal to Porter stemmer. Now we input whatever we want to insert into the stemming. Now we've given the word as writing and the output will be write. When we give the input as eating, the output is eat. And in a similar fashion, If we enter word, if we input word stem or dot stem, and give the input as learning, since we are learning natural language. Learning, the output would be the root word, which is learn. A complete implementation example would be like import NLTK, as we mentioned earlier here, import NLTK. From NLTK.stem, import porter stemmer, which we performed earlier. And then we would give the input as word stemmer.stem writing, and the output would be write. Next, the second stemming algorithm that we will be looking into is the Lancaster stemming algorithm. Lancaster stemming algorithm was developed by at the Lancaster University, and it is another very common stemming algorithms. NLTK has Lancaster stemmer class, with the help of which we can easily implement Lancaster stemmer algorithm for the words we want to stem. Let us see an example. The first step, even in this algorithm, remains the same, that is importing the NLTK library. Now importing the Lancaster stemmer class to implement Lancaster stemming algorithm. Even the second step remains the same, only difference is that we are importing a different library here. Notice how in the previous algorithm it was the Porter stemmer, now it's Lancaster stemmer. Next, an instance of the Lancaster stemmer is taken, Lancaster underscore stemmer equal to Lancaster stemmer, and then we input the words we want to stem. Lancaster stemmer dot stem eats, the output is eat. Notice how this library is very similar to the previous one. The steps involved are three, which is importing the library, importing the stemmer from that particular library, then creating an instance for that stemmer, and inputting a word into that stemmer. In a similar fashion, the Lancaster stemmer works, producing the output as eat for eating, learn for learning, write for writing, and so on. The third stemming algorithm we will be looking into is the regular expression stemming algorithm. With the help of this stemming algorithm, we can construct our own stemmer, regular expression class. Natural language library has regular expression stemmer class, with the help of which we can easily implement regular expression stemmer algorithms. It basically takes a single regular expression and removes any prefix or suffix that matches the expression. Let us see an example. In the first step, similar to the previous algorithms, we import the NLTK library, and then even in the second step, we import a particular package from that library. For this algorithm, we import the regular expression stemmer library. Next, we create an instance of regular expression class and provide the suffix or prefix you want to remove from the word as follows. Now here is where the change comes about. Notice how in the previous two algorithms we gave the input as the word which needed to be shortened. So we give the longer word, but in case of regular expression stemming algorithm, we're giving the input as the part of the word which we want removed. Now input the word we want to stem. Regular stemmer dot stem eating will remove the part which was entered earlier. Hence ing is removed. Now since ing is the input given to the regular stemmer here, ing is removed wherever it occurs in a word. In this example here, ing eat, from ing is removed. Now if we take an example of learn, L-E-A-R-N, but if we input the word or letters, in fact, ing in between the word learn, does not make any sense. But for the sake of example, let's assume there exists a word called Learn. Now, since ing exists, now in this case, if such a word existed, we would assume that ing would be extracted out and the word learn would be given out, right? Because ing is given as the input here, so we would assume that ing would be removed, right? But this is not the case. Why does this happen? Why is ing not removed in this case? Notice how we mentioned that only in the prefix or suffix the word is removed. So ing is removed only if it exists in the suffix or the prefix. If it exists in between a particular word, it shall not be removed. The complete implementation of this example is as follows. Import the library, from import the particular package in that library, instantiate the function, and give the output. There's a mistake in this here. Before the closing bracket, there should be ing, and this would remove all the ings from the suffix and the prefix only, not when it occurs in the middle of the word. The fourth and the last type of stemming algorithm we will be exploring here is the snowball stemming algorithm. Snowball stemming algorithm is another very useful stemming algorithm. NLTK has snowball stemmer class, with the help of which we can easily implement snowball stemmer algorithms. It supports 15 non-English languages. Notice how the previous three stemming algorithms worked with only the English language, but snowball stemming algorithms works with 15 non-English languages. In order to use this stemming class, we create an instance with the name of the language we are using and then call the stem method. Let us see an example. The first two steps remains the same, and that is importing the NLTK library and importing that particular stemmer package from the NLTK library. And then we give the syntax as snowball stemmer dot languages. to indicate which are the 15 languages, which are the 16 languages, including English, which can be processed using the stemmer. The 16 languages are Arabic, Danish, Dutch, English, Finnish, French, German, Hungarian, Italian, Norwegian, Portuguese, Romanian, Russian, Spanish, and Swedish. These are the set of 16 languages which can be shortened, which can be used with the stemmer. The stemmer, which can these are the 16 languages the stemmer can work upon and shorten the long word into a small root word. After the creation of Snowball Stemmer class with the language we want to use, we create stemmer for the French language here. French stemmer. This is the basic step of instantiating the method, and then we call the stem. Bonjour. The word bonjour in French means hello. Hello. And hence we try to find the root word of this word. Bonjour is basically a variation of hello in French, but the root word remains bonjour, which means hello. So the root word is extracted here, and bonjour is given out as the output. The complete implementation example in this case is as follows. We import the natural language library, and then we import the package from that library. We create the particular language for this stemmer. We given the input as French, and then we input the word we want to stem, and then we form the output.